question 8, differentiating then when it comes to ln, right, ln x, differentiate becomes 1 over x, doesn't it? Okay, that's the rule for ln x. So of course when there's a function inside, you've got to treat it like as a function of a function, so you differentiate ln using the method. Okay, so we have 1 over it, like we got here, 1 over this stuff here. Then because it's a function of a function, you then got to multiply by then the derivative of the inside function here. So the derivative of this is, well, that becomes 8x, that becomes minus 3. Okay, so put a bracket around that, and then you should tidy this up. Okay, so 8x minus 3 on the top, 4x squared minus 3x minus 5 on the bottom. Okay, part 2, might be better to rewrite this as e to the power x power half, okay, rather than root x. dy dx then, now you've got to remember e to the x stays the same, doesn't it, and differentiate. That's what it is, the derivative is e to the x. So in this case, it will stay the same, e to the x power half, but you've got to, because it's a function of a function, you've got to times it by the derivative of the inside function. So differentiate this, well, differentiate x power half, you bring the half down, x, and then you take away 1, don't you, from the power, so it'll be minus a half. Okay, so you end up with that there. Okay, so we could sort of tidy this up a bit. We could e to the x the half over 2x the half, yeah, because you bring that down, okay, because it's minus power, and then you could even rewrite that as e to the root x, go back to the root over 2 root x, okay, because it's x power half. Okay, and try and do things like that, because they do expect you to simplify as much as possible, and you'd lose marks if you didn't. Part 3 then, okay, so we've got y equals a plus b sine x over a minus b sine x. Okay, so straight into a quotient rule type question here, right? Quotient because you've got one function divided by another function. Okay, so the top, think of this as a function, bottom, think of this as a function. Call the top u, call the bottom v. Okay, we set it up like this, then you do du dx. We differentiate this. Now in the question it said a is a constant, right? So we differentiate that as 0. b sine x, well, sine x becomes cos x when you differentiate it, so there's a constant in front of it, constant b, so just call it then b cos x. dv dx, remember now a is a constant, so it just goes, disappears, minus b sine x, well, sine x becomes cos x, as we said earlier when we differentiate it, but we've got a minus in front, so minus b cos x. Okay, then the quotient rule then, dy dx equals, you need to remember this, v du dx minus u dv dx all over v squared. Okay, so I'll run out of room here, so I'll go on the next page here with this. So quite simply, when you use the quotient rule, it is sort of like crisscross, yeah? So you start over with a v, don't forget, right? So important, a minus b sine x, put in a bracket, times then du dx, which is b cos x. Take away then u, which is a plus b sine x, times then dv dx, which is minus b sine x, minus b cos x, right? All over then v squared. Now where's v? V is that there. Now when it comes to simplifying this now, okay, key thing is don't do anything to the bottom, leave it as it is, okay, because that's as simple as you get it. If you expanded the bottom, you'd end up on 4 terms, and keep it like this, as simple as you can get it. The top though, it is worth expanding because you can make this a lot simpler. So multiply through that first bracket by b cos x, that'll be ab cos x. Here then b sine x, b cos x, so that'll be minus b squared sine x cos x. Okay, onto this bracket then, now you times in by minus b cos x, there's already a minus there, okay, so there's minus out here and there's a minus here, so we could actually eliminate those minuses, okay, because 2 minuses make a plus, okay, so we'd end up having pluses here now, okay, so b cos x times a is ab cos x, and then b cos x times b sine x will be b squared sine x cos x, okay, and of course then all over a minus b sine x all squared. Now what's great is this cancels with this, and we end up on the top then having 2ab cos x. Okay, 2ab cos x over then a minus b sine x all squared, and it's job done.